Hello everyone, are you able to hear me? If you all are able to hear me, please can you put a message? Let me post here. Are you all able to hear me? Yes or a no? Let me respond here. Please give a poll. Wonderful. So roughly 80% of you all are able to see my screen. That's a good thing. Okay, and also I think Narendra, you're asking that question again and again. This is not the right forum, I believe. Okay. And people who have not received LMS access, please do not worry much on this front because you will be receiving LMS access. You should have received by now. A few reasons why you would not have received are as follows. Just a minute, sorry. Just give me a minute. Okay, sorry about that. Some of the faculty started YouTube channel in Telugu. Can anyone share that YouTube link? Okay. Yep, I know. A lot of you all have received. Thank you so much for responding, right? If you have not received, because I'm also receiving a lot of WhatsApp messages, so is our team. It would be a disturbance because three reasons. Either you attended only 1 day or 2 days, or you joined at the last moment for the certificate purpose. All those could be the reasons why you haven't received. Another reason is maybe you did not even fill the attendance form. The third reason is maybe you did not fill the LMS application form, LMS access. We discussed this, right, on Friday. If you have not done any of these, then you would not be receiving AI Spry or Learning Management System access. If you have done all these, then we would have sent you for sure. Okay, because that is an automated process. And please check your promotion tab in Gmail. When you open Gmail, there'll be promotion. Please check there. You should be able to see there. For sure, you will be seeing there. Okay. If not, worst case, you will find it in spam folder. If you still claim that, do you know what? I've done everything possible, yet I have not received. Then please drop an email to prasad at 360digitmg.com. But then we are going to cross check whether you have filled the application form or not. We will cross check whether you have attended the sessions or not. And then we will provide you with access. Just dropping an email would not mean you'll get access because we want only those people who actually attended to be given access, right? So we'll check your attendance and we will then give you the learning management system access. But from the time you send an email, please expect 24 hours. Within 24 hours, that this is our SLA, service level agreement. Within 24 hours, we are going to respond. Sometimes it'll be as fast as 10 minutes. Sometimes it might be 2 hours. Worst case is 24 hours. Okay, so this is the ground rule, and then I think we should get started now. Once again, welcome to the faculty development program on artificial intelligence and deep learning. We will quickly do a recap on whatever we have discussed until now, and then we will proceed further. Okay, and once again, I need to prove you all because you keep saying that voice is not audible. This is my internet speed. Okay, it is roughly 100 Mbps. That means if you are not able to hear me or not able to see the screen properly, you know that internet issue at your end is causing that problem. Okay, once again, I'm proving it live by doing a speed test so that you frequently do not send such messages on the chat window, because a few people might have serious questions, right? We might miss out because of too many questions. That's the only reason. So here we go. 88%, 88 Mbps is the download speed and 80 Mbps is the upload speed. I'm pretty sure this speed is amazing. Okay. Now let me also put these two statements here, which will set the tone. Almost 85% of the participants are able to hear me and see the screen. This means you have audio issues or internet issues at your end. So please fix those audio and internet issues and rejoin. Okay. Please do this because of multiple reasons. Frequently you'll be putting that message no audio, etc. No audio means it is taken that issue is at your end. Why? Because 85% of participants are able to hear me and see the screen. Okay, this means audio issues and internet issues are at your end. Please fix it. Please don't keep sending that message. Okay, because important questions might be missed out. All right. So now let us get started with the mind map, and let us do a quick recap on what all we discussed as part of our 3-day session, and then we'll get into the sessions. Okay. Whenever you work on any data related project, the first thing that you need to remember is that you need to have a proper structured approach or structured methodology in handling your projects. You need to have a proper project management methodology in place. And this project management methodology is CRISP-DM, which stands for Cross-Industry Standard Process for Data Mining. Cross-Industry Standard Process for Data Mining. This is a very structured approach. Okay, and then the first step on any project management methodology or any project for that case is to understand the business problem. Once you understand the business problem, we need to record the business objectives and business constraints. Once that is done, you proceed further to the next step, which is data collection. Even before you move on to data collection, you should be aware of the various data types, wherein we have continuous data, discrete data, qualitative, quantitative, right? And then you have structured, unstructured. We discussed about all of these techniques. Once you understand about the data types, then you proceed further with data collection. And within data collection, you have a lot of data collection techniques wherein out of all those various data collection techniques, these are the two techniques which are extremely important, which is primary and secondary. Once you have the data at your disposal, you need to perform data cleansing. Of course, there are a lot of data cleansing techniques which exist, which are listed down here. And then you perform your exploratory data analysis, graphical representation, wherein you have all these plots which exist, and bivariate. Everything is clearly listed down. What are the secondary purposes, primary purposes, what is, you know, correlation coefficient, all of that, and then feature engineering. After this, we have also discussed about machine learning. Okay, and as part of this, we discussed about machine learning primer. What do we do as part of machine learning primer? We split the data into training, validation, and test. You build your model on the training data and you try out various hyperparameters on your validation data. And once you figure out on what is the best combination, then you proceed further with testing. Okay, and with the right hyperparameter settings, you test on your test data, and then you get the testing error or generalization error. And one more thing worth discussing is that auto ML is being worked upon in a very big way. This means that probably if a student joins in first year, okay, and say you have freeze the curriculum for the next 4 years, right? I am 100% certain, not 99% certain, 100% certain that this curriculum, by the time the student completes 4 years, will become obsolete. And hence, we need these kind of periodic sessions, faculty development programs, which will bring in the latest of the enhancements. Okay, that is very, very important. Okay, and then not just that, we also have this auto hyperparameter tuning. And then we have testing. You test on the test data and then you get generalization error. And then you compare your training and test error. If your training error and test error both are small and close to each other, it is called as a right fit model. Okay, and then if the training error is low and testing error is high, then it is called as overfitting or variance, which is also called as regularization technique. If both training error and testing error are high, then it is called as underfitting or bias. To fix this problem, you do various things such as increasing the amount of data, etc. Okay, so this is what we have discussed, and today we will discuss about loss, error, and cost function, and how are they very relevant in the world that we live in, and how is it very important for our deep learning algorithms. Okay, but then before I proceed further, once again, two quick things. Almost 85% of participants are able to hear me and see the screen. So if someone is not able to hear me or have internet issues, please fix those issues and rejoin. And next important thing is this. If you have not received LMS access, then you did not attend all the classes, or you did not fill the attendance form, or you did not fill the learning management system access application form. If you have done that, then if you feel you haven't received, then that is incorrect. Please check carefully your promotion tab in Gmail. Go to your Gmail, look at your promotion tab, and also check your spam folder as a worst case. Usually it doesn't go, but it might be there. If you still do not find it, and if you say that, no, I filled the application form, I attended all the classes, then please drop an email to prasad at 360digitmg.com. He's going to ensure that he provides you access within 24 hours max. This is the maximum SLA. You might receive it in the next 1 hour and maximum of 24 hours. Yep. But then please do not drop an email saying that I filled the application form, because we will go and check there. And if you do not find it, obviously it doesn't look good on your part as well as our part, right? So please abide by this. Now, as usual, we have this lucky draw. So let's have that. Yeah, exactly. But in auto ML also, you need to know what parameters to change, Narsimha Reddy. If you don't know which parameters to change, what will you do with that? Right? Automation is everywhere. Okay. Hope that answers your question, Narsimha Reddy. Okay. And now what we shall do is, those who have actually addressed or responded to the quiz questions will quickly give away the prize now. Enoch, would you like to take control of the screen and just quickly do that within the next 1 minute or so?
Okay, Bunny, just give me a second.
Yeah. So we will quickly do that lucky draw and then proceed further. And until then, since people are still sending the emails despite seeing these, so I'll put this for quick 1 minute. Please read these 4 lines carefully, and please do not send any emails pertaining to LMS access on the chat window. That's a humble request, because it doesn't help. Because I have already given you a solution to this.
All right, Bunny, I'm ready. So let me just share my screen.
Go ahead, please.
Yeah. So we have already extracted the list of people who have responded both on LinkedIn and Facebook. And we have about, let me see, we have about 318 people. So serial number 1 till serial number 318. So just to make sure that we are fair in our picking of the winner, we are going to use Google random number generator, which will give us a random number between the range that we specify. So I'm going to specify the range number 1 to number 318. So maybe just to just to test it, I'm going to give 100 and see if everything is good. So as you can see that it's randomly generating the number. So now I'm going to give number 318. And the moment I click on this generate, whatever number comes up here would be our winner for day 3's quiz. So without any further delay, let's do this. 3, 2, 1, and go. So we have number 302. So let's see who that lucky person is. So 302 is Sudhir Kumar Koduru. So congratulations, Sudhir Kumar Koduru, if you are in the session. Congratulations for winning, and our team will contact you and we will give you further details on how you will get your gift. And congratulations once again, and over to you, Bernie.
Enoch, can you put the YouTube link here where they can see the videos?
All right, I'll do that. I'll just put it in the sticky notes.
Play Koduru. And Mr. Shyam has this question. Shyam says, hey, where do I find this? I don't find the videos. Shyam, I think we can share this link so that you might find it.
Sham, you can see the link on the sticky note, and I'm also putting the link in the chat.
Here?
And yes, there you can watch all the recorded videos. All right.
Yep. When you just click on that link, you'll see here all the 3 days, and today is the 4th day. That also is available, but then it's getting streamed here. Already 1796, roughly 1800 people have viewed. So they are able to view the access. Wonderful. And Mr. Nagaraj, have you seen this? Have you seen this? Please see this and read this, please. Mr. Nagaraj, you might want to read this quickly. Yep. I request Mr. Nagaraj to read this quickly and please act accordingly. Maybe you might want to just drop an email to Prasad and then you would receive the LMS access. Okay, friends. So no more discussions on LMS, please, because we are getting delayed with respect to the topics that we need to learn. So please read this carefully, take a screenshot if need be, and yep, we should be good to proceed. Okay, how to use LMS quickly, let me tell you. When you log into your AI Spry access using your username and password, you need to click on this and go to my courses. When you click on my courses, the courses that you have enrolled for, that is AP State Skills Development Corporation and 360DigiTMG Faculty Development Program on AI and Deep Learning, you'll find this. Just click on that. When you click on this, you will have the study material. Here are the modules which are available. And you'll have the quizzes corresponding to that. Just click on this, your machine learning primer, you will experience all these slides, right? You'll have all these slides. And we have discussed until here model evaluation and tuning. Though I haven't driven myself using slides because I'm not slides driven tutor. And you can just click on next. We are here as part of, now this, yeah, here we are. So this is what we are going to discuss from slide number 19 onwards. But then once again, I will try my best to make use of these kind of numbers, and then on Excel sheet I'm going to do it practically so that you understand it in a better way, better manner. So what I shall now do is I shall quickly replicate these numbers and then we shall discuss. Say, for example, you have tried building two different models, model 1 and model 2. When you have used model 1 and model 2, you would obviously get the actual data. Or so, sorry, let me explain it in this way, that say you have used model 1, machine learning model 1 for prediction. When you used model 1 for prediction, maybe your model predicted that your sales will be $101, but actually your sales was only $100. Okay, your model predicted that sales will be $101, but actually your sales was $100. then there is an error, obviously, because of your model 1. Error of model 1 will be predicted values minus actual values. You can say that. So I'll write it down here. Predicted values minus actual values will give you error. And then say for the next month, this is for say for the month of Jan, for the month of Feb, for the month of March, for the month of April, you have the data in that way. Error is predicted value minus actual value, and then say you got 1. Then for the next month, that is for the month of Feb, you predicted that your sales will be $199. But at the end of the month, when you checked, your sales was only say $200. So error is predicted value minus actual value, which will give you -1. Then say you have for the third month, and then your third month, you predicted that your sales will be $301, but actually say it was $300. And the error is predicted value minus actual value, which is 1. And for the fourth month, you predicted that predicted values will be 399, but actually it was 400. Then the error is -1. Okay. Then say you thought, okay, let me now try a different prediction model. So then you tried out a different prediction model altogether. I would say model 2. When you tried out your model 2 machine learning algorithm for prediction, why this? I'll remove this. Okay. You know that model means it's the predicted value. Okay. So here, when you build your model 2, say your model predicted that sales will be $110, but actually your sales was $100. So what will be the error for model 2? Error is actual value minus, sorry, predicted value minus actual value, which will be 10. Friends, remember one thing, error need not always be predicted minus actual. You can also say actual minus predicted. It does not matter. Why? I'll get to that. So for the next month, say when you use your different model, it predicted that your sales will be $190, but actually your sales was $200. So when you subtract these two, you get -10. And for the third month, when you use your model 2 to predict, say your sales was $310, but actually it was $300. So when you subtract these two, you get $10. And finally, for the fourth month, when you use your model 2 to predict, your model predicted that sales will be $390, but actually it was $400. So when I subtract these two, you get -10. So this is the data that we have. Now, there are different ways of measuring your error when your output variable is continuous. Very, very important. Okay. These error measures are very, very important. If your output variable is continuous, then there are different ways of measuring the error. Out of that, one is called as mean error. Mean error. Mean error means average of all these errors, right? So if you just want to calculate the mean error, mean is nothing but average. When I take an average of all these numbers, 1 minus 1 plus 1 minus 1 divided by 4. When you do that, you get 0. So average of these numbers is 0. And when you take average of all these numbers, you get 0. So the mean error is 0. If you take only mean error, okay, if I say mean error is equal to 0 for both model 1 and model 2, then what can you conclude? Quick poll question coming your way. What can you conclude? Let's see. So if I were to ask this question on, reset this and ask question. If the error is, if the mean error is equal to 0, then what can you conclude? Mean error is 0 for both model 1 and model 2. Then what can you conclude? Model 1 is better. Model 2 is better. Both the models are the same. Yep. Can you answer? Please, can you answer? If the mean error is 0 for both the models, then what do you conclude? Amazing, friends. Amazing. Roughly 85% of y'all are saying that, hey, if mean error is 0, both the models are the same. Absolutely, you're right on that. And this is a disadvantage with mean error. But then if you look at the underlying data, you know that model 1 is better than model 2. But for that, you need to go and look at the underlying data. If you just look at the mean error, that means both the errors are the same. Since both the errors are the same, you need to counter this. You need to solve it. How do I solve it? Then people thought a lot, and they thought, okay, I think instead of mean error, we can take something called as mean absolute error. What does that mean? This means that you just take modulus for each and every error. Say you have all these numbers. If you take modulus of all these numbers, what do you get? Modulus of 1 is 1. Modulus of minus 1 will be 1. Right? So you have all ones. When you take the mean of these numbers, what does that mean? You add all these numbers and divide it by 4. So 4 by 4 will be 1. You'll get mean absolute deviation as 1. Now if I take absolute values for all of these numbers, then you get 10 throughout. And mean absolute deviation for all these numbers is 10. So if you look at mean absolute deviation, model 1 has a number 1, model 2 has 10. Now, if I were to ask the same question yet again, but with a slight twist in the tail, let's see what will be the right answer. Which model is better? Model 1 or model 2? Answer questions are model 1, model 2, and then both models are same. Please, can you respond to this? Which is better when you look at your mean absolute deviation? Model 1, which has mean absolute deviation 1, or model 2, which has mean absolute deviation as 10? Deviation or error mean the same, okay? Mean absolute error or mean absolute deviation mean the same. Deviation means How much is your predicted value deviating from the actual value? Okay, that is what it means. Okay, now let me look at your responses. Wonderful. Model 1 is the right answer. Why model 1 is the right answer? Because less the error, better is your model. Less the error, better is your model, right? You don't want high error, you want less error, less mistakes. Okay, this is the next thing. Then, so you have 1 and 10. Let me just write it down here. You get 1 here and you get 10 here. Wonderful. So we are done with this also. But when it comes to integration, derivatives, when you have absolute values, it doesn't work. It will give you cannot proceed further. Why can't you proceed further? To know more, you'll have to bear with me because we will do mathematical foundations also, and then you will understand better. So let me do this. Let me do this also. Now, since you cannot do any derivatives when you have mean absolute deviation, people thought, okay, to get rid of this plus and minus sign, right? To get rid of these minus signs rather, because it's canceling out, right? When you have plus 1 minus 1 plus 1 minus 1, it's getting cancelled out and you're getting 0. Same is the case here also. Plus 10 minus 10 plus 10 minus 10, they are getting cancelled out and you're getting 0. Hence, to counter this, we have we have been trying out various techniques, and we will now try out mean square error or mean squared error. So what you do is you have all these values, right? So this is $1, minus $1, $1 and minus $1. You square it. You get $1 square. Minus 1 will become $1 square because units get squared. $1 square, $1 square. And here also it's $10 throughout, minus $10, $10 and minus $10. When you square it throughout, you get $100 square, $100 square, $100 square, and you get $100 square. Okay, since you're getting $100 square and you have your mean squared error here, you get, when you square all these numbers and when you take average of these numbers, you get $1 square. You get $1 square actually. Where did that go? Just give me a bit. Okay. I think here there won't be any, yeah, superscript exists. Okay. It's going to be $1 square. And here, when you take average of all these numbers, you'll get $100 square. Here you get $1 square. Here you get $100 square. Dollar square is a disadvantage with mean squared error. So I'll also mention here the disadvantages associated. If you have mean error, then it does not capture the underlying data if you have positive and negative values, and we face a risk of these positive and negative values getting cancelled out. they might get cancelled out. So that is the risk that we are facing. And if you look at mean absolute error, the disadvantage with this is that we cannot perform derivatives or calculus when we have absolute values. Why? We will discuss that when we discuss about mathematical foundations. Okay, and then okay, mean squared error. You are using mean absolute error or mean squared error to get rid of this positive and negative signs. But then here, the disadvantage is that units are getting squared. You're getting square of errors or square of units rather. So if you want to counter this problem, what you can do is you can find out something called as root mean squared error, which is called as RMSE. Root mean squared error, that is simply put, take the square root of this. If you take the square root of that, you would get $1. And if you take the square root of $100 square, 100 square root is 10, and dollar square will become dollar. And so you have root mean square error also. So this doesn't have any disadvantages is what we might feel, but then there is a disadvantage with this also. And the disadvantage is that it gets influenced by units. Hey, what do you mean by that? What do you mean by that? What I mean is, say you have two AI teams, one artificial intelligence team A, which sits in India, and say you have another artificial intelligence team B, which sits in USA. The team in India might be using the units in rupees. So if you calculate this error in rupees, $1 will become 75. So the CDO, Chief Data Officer, say asks team A, on team A, what is the error that you got? Team A would say 75. Say the team in US is using US dollars and they got $1 as error, so they'll say 1. If the Chief Data Officer asks a question on, hey, what is the error? Team B might say it's 1. Then Chief Data Officer will quickly think that Team B is doing a good job because they're saying error is 1. Team A is not doing a good job. 5. Is this right? No. Both the teams are actually doing the same thing. They got the same error. Just the units are different. Just to ensure that people do not get confused because of the units that they are using in the model, people take percentage error. Okay, and that is called as mean percentage error. That is called as mean percentage error. Okay, let me ask this question even before I give you the formula for this. If I say 10 out of 100, what percentage is this? What percentage is 10 out of 100? If you have 10 out of 100, what percentage is that? Quickly, please respond. on the chat window, what percentage is 10 out of 100, friends? How do you calculate that? 10 divided by 100, and then you get 0.1, multiply it with 100, and then you get 10%. If you want in percentage terms, 1 out of 100 will be 1 divided by 100, which is nothing but 0.01. Okay, but then if you want this in percentage terms, you multiply it with 100 and you get 10%. Sorry, 1%. Simple. So 10 out of this or 1 out of this will give you percentages. Very simple. On similar lines, if you want to calculate mean percentage error, it's nothing but how much error do you have out of overall actual value. So it's 1 by 10 for the month of Jan. For the month of Feb, it is how much error do you have out of the actual value, which is minus 1 by 200. This is for Feb month. For the month of March, it is 1 out of 300. So 1 out of 300 is your percentage error. What percentage is minus 1 out of 400? It's minus 1 by 400. Once you get these percentage errors, you add all these errors and then take an average divided by 4. That is called as mean percentage error. That is how you calculate the mean percentage error here or here. The advantage with mean percentage error is that it is not influenced by units. So the challenge that you have here is getting addressed in mean percentage error. But again, if you ask me a question on, is this the gold standard? Don't we have any disadvantages with this? Then my answer is again no. Why? Because again, your positive values and negative values might get cancelled out. And you might once again end up with the same problem that we were having. So let me put here. So positive and negative values get cancelled out. That is a disadvantage. For example, assume that this was 1 by 100. And just for now, assume that this was minus 1 by 100. And next it was 1 by 100. And next one was minus 1 by 100. Assume for now, okay? So if you have plus minus sign, if you take an average of that, this will get cancelled out. You get 0 by 4. Again, you run into the same kind of an issue that we experienced in mean error. Again, we get into the similar kind of issue. Hence, what people have done is they thought, okay, we have a solution here that is pretty simple. If you can calculate mean absolute percentage error, then it will solve the issues in a big way. So we have mean absolute percentage error, and it is nothing but once you take the percentage, which is 1 by 100, say you have another value minus 1 by 100, 1 by 100, and minus 1 by 100. If you have such 4 error values or percentage errors, if you take an average directly, you'll get 0. So you take absolute values of all of these. And then take an average of that, which will be 1 by 100 plus 1 by 100 plus 1 by 100 plus 1 by 100 divided by 4. That's it, simple. So the mean absolute percentage error is the best solution until now. Is this foolproof? I would say not really. We still have certain issues in this, but then we will confine our discussion to these 6 errors which we use when your output variable that you are predicting is a continuous value, and it is given in two locations. One is on our slides and another is, it'll be there here, mean error, mean absolute deviation, squared error, root mean squared error, percentage, and mean absolute percentage error. But then for very easy quick access, you know that our mind map will serve handy, because if your output variable is continuous, you have all these various ways of measuring your error. And if I say that error is 3%, then what would be the accuracy? Accuracy will be 97%. Error is 3%, then accuracy will be 97%. And the relationship between these two is that accuracy percentage plus error percentage is equal to 100%, or accuracy plus error is equal to 1. Okay, that's how we calculate, and that's the relationship between accuracy and error. So we just completed on what are the error measures if your output variable is continuous. Let me rename this as output is continuous. Now another question that we need to answer is, what if the output variable is discrete? What if the output variable is discrete? Then how do you go about handling this? And I should say that we are going to quickly discuss about three things. One is, I'll explain you on what is entropy and how to calculate that. I'll explain about what is cross entropy and how to calculate this, and what do you mean by KL divergence. And before we get into entropy, cross entropy and KL divergence, there is another concept which is called as information theory 101. If I can explain these four, then you will understand on how to look at the cost function, etc., for this output variable discrete. Okay, and certainly we will get to that. But then even before we proceed further with this, I need to explain to you all about information theory. And information theory means, let me make certain statements here, and I want you all to tell me on what is the information that is contained in it. If I say sun rose in the east today. Today, do you know what? Sun rose in the east. Okay, if I make such a statement, what do you think is the probability associated with this? Okay, let me put a quick poll question here on what will happen if the statement is sun rose in the east. If I say sun rose in the east, there is 100% probability. So probability will always be equal to 1. And what additional information is available in this? If I say sun rose in the east, the information content will be very less. Will be very less in terms of bits. And then if I say weather is cloudy in London, people who are in London would say, oh, weather is cloudy in London. Everyone knows that. So majority of the days probability, weather is cloudy. So probability might be very close to 1, maybe 0.95. Sometimes you also see sun. And you know what? How do you know? How did this term called Sunday come into existence? Because once in a while, sun used to come out in UK, and then they used to declare it as a holiday. The moment you have sun coming out, people used to enjoy, saying that, hey, hooray, today's sun has come out. From that, this term emerged, Sunday. Literally, that's how it has emerged. Okay. Here also, information content will be very low. Why? Because this is not a breaking or flashing news that it's cloudy in London. Majority of the days where weather in London will be cloudy. Right? Hence, probability is 0.95. Now, if I make another statement that a baby was born in our community, obviously you will not have babies being born every day, right? Probably babies will be born only on a few days. So here, probability will be, could be 1 in every 365 days. Once in a year, a baby is born in my community. Certainly, there will be high information content. Because this is the news. I will change this in this way. Okay, and then if I say there was an earthquake on a richer scale, earthquake was 7 in Malaysia, in KL, Kuala Lumpur, in Malaysia, then this certainly becomes a flashing news. Because do you daily hear that there is an earthquake? No. Do you at least hear it once in a year? No. You might hear once in a decade. So 10 multiplied by 365 days, it's going to become very rare event. Since it's a very rare event, information content will be very high. Information content will be very high. Okay, then since the information content is very high, the probability will be very low. In this scenario, the relationship between how much information is contained in an event is inversely proportional to probability. Okay, and you take log of 1 by probability. And then here, if you take this probability to the top, it will become minus log of probability. If you just take it. Why did you take log? Because log has certain additional advantages when it comes to doing certain derivations. Okay. So what does this mean? This means that rate the event or rarest let me write it properly. Okay, rarest, or I'll put it this way. Rarer the event, higher the information content. Okay, if a specific event like earthquake is very rare, so there is going to be high information content in that. And also we discussed that probability is nothing but minus log of, information content is equal to minus log of probability, right? It's inversely proportional. Right? Information content is inversely proportional to the probability. And why do we take log? For some calculus derivatives purpose, for simplicity. That's beyond the scope of our discussion. Okay, that's about information content which you need to be aware of. And now, since you're aware of that, if you have high information content, okay, if you have high information content, means rarest of the events, that means your data has a lot of purity, right? If you have low information content, that means you'll have a lot of impurity, means all junk data, junk news. If you see any news channels telling you obvious things, you'll say, hey, these people are junk. They cannot generate good quality content. This impurity measure is called as entropy. So entropy is nothing but impurity. And how do you actually calculate entropy or cross entropy or KL divergence? We will get to that. Okay, now, okay. So let me quickly discuss about entropy also. And then once we discuss about entropy, we will take a quick break, or is it? Let me ask this question here. Oh my God, log of probability can be negative, Prasanna. Yep, that's the reason. Yeah, you're in some sense right, but then as I've told you, Shakina, you'll have to take log for certain mathematical reasons. Yeah. Okay. How can we maximize entropy without changing the data set? Okay, fine. So let's proceed further with entropy discussion so that you understand things better. Where did that go? I think I put it here. Yep. All right. So now you have here three inputs: ball size, ball color, and price. You have these three. And then you want to predict your output on whether it is useful for play or not. A ball is useful for play or not. Now we will see whether there is going to be any entropy or impurity when I use ball size here for decision making. If I use ball size for decision making, then you know that it's a two-class problem. Two-class problem means either it is useful for play or not useful for play. So you have two classes, yes, or you have a no. You have a yes or a no. Now, if you look at this ball size, I can come up with a rule which says less than or equal to 50 and greater than 50. And we've already seen, what did we see? Information contained is inversely proportional to the probability. If someone says sun rises in the east, then what is the information? There is no additional information in it. There is no meaningful information. Why? Because the probability of that event occurring is 1, right? So 1 by 1 is 1. If I say there is an earthquake in KL, Malaysia, then it's very, very rare. So the probability of that event occurring is very, 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 very rare. 1 by 0.001 will be what? 1000. So there is high information contained. Hope it's making sense, guys. Now, people take log for various mathematical reasons. It's log of 1 divided by probability. And when you take probability on the top, it becomes minus log of probability. And hence, you have minus log of that in the entropy formula. And also, entropy is a measure of impurity. In some sense, it is a measure of error. Hence, you have a minus sign. That's fine, right? Now, let me calculate the entropy here and show it to you guys. So, okay, now this is fine, I think. Let me reduce these and let me erase these things. All right. So we have this problem that we are trying to solve, and we have taken ball size. Okay, I just want to ensure that these things do not appear. So I'll just delete that. Hmm. So that it's easier for me also to explain. All right, now here you have a two-class problem, yes and a no, right? So you write it as minus summation of I equal to 1. You have a two-class problem, so n will be 2 into probability of xi into log of probability of xi base 2. You will have base 2, 10, e, different bases will be there. Then if you were to expand this, you get minus I equal to 1 will be p of x1 into log of p of x1 base 2 minus, if I substitute I equal to 2 here, p of x2 into log of p of x2 base 2. Now, what is p of x1? For the left hand side, if you look at this, this is your left hand side is less than or equal to 50. If you look at less than or equal to 50, I would take only this portion. You take only this portion, right? The upper portion. Now here, if you take only this upper portion, then how do you write it? You write p of x1 as how many times you have yes. How many times do you have yes in these three? 3 out of 3. And 3 out of 3 is 1. How many times do you see no here? Only 1 out of, sorry, 0 out of 3 times. And 0 by 3 is equal to 0. So if you want to just substitute, p of x1 will be 1. So it will be minus 1 into log of 1 base 2 minus 0 into log of 0 base 2. Log of 1 is 0. So minus 1 into 0 is 0. 0 into anything is 0. So overall you'll get 0. For the left hand side, entropy is equal to 0. That means there is no error, kind of, right? Now if you look at the right hand side, on the right hand side, let's see what is the entropy. Just erase these, which can be written again. This is a right hand side because it is greater than 50. Ball size greater than 50. Yeah? So you have no. Now if you want p of x1, How many times do you have yes out of these two? 0 times. So it will be 0. How many times do you have no out of 2 times? 2. 2 out of 2 will be 1. So you will write this as minus 0 into log of 0 base 2 minus 1 into log of 1 base 2. 0 into anything is 0. 1 into log 1 is 0. It will be 0. So entropy towards the right side also will be 0. So total entropy also will be 0. Total entropy will be 0. Why 0? Why do you think it is going to be like that? Let's see. Oops. Okay. So if I take this first row and take this ball size, it's 10. Is 10 greater than 50? No. Is it less than or equal to 50? Yes. So what will your model say? Your model will say that this ball will be useful for play. So if I just look at the first row, predicted values, it will say useful for play. This first row, what will be the actual value here? Actual value says, yes, it'll be useful for play. That means there is a match. Now let's take the second row. Here, ball size is 1. Is 1 greater than 50? No. Is it less than or equal to 50? Yes, it's less than or equal to 50. If it is less than or equal to 50, what does your predicted value say? Yes. And what does your actual value here say? Yes. Now let's take the third row. Value is 50. Is 50 greater than 50? No. Is it less than or equal to 50? Yes. This 50 is less than or equal to 50. So your predicted value will say yes. And what does your actual value say here? That also says yes. So there is a match. Now let's take the fourth entry, which is 100. Is 100 less than or equal to 50? No. Is it greater than 50? Yes, greater than 50. So for this fourth one, if it is greater than 50, predicted value says no. But let's see what our actual value has to say. Oh, that also says no. Wonderful. And finally, let me take the last row here. You have 1000. Is 1000 less than or equal to 50? No. Is it greater than 50? Yes. Greater than 50 means your model is going to predict as no. But then what does your actual value say? This also says no. Wonderful. There is no misclassification here. Hence, error or impurity is 0 here and 0 here because there is no misclassification. Let us do this for maybe price and see what happens. Okay. Left and right would be fine. Instead of this, we will take price, and then we're going to look at predicted and actual values. Okay. Now we don't know what's the entropy, so we will calculate both these entropy values. And let me remove these also. Yep. Let's do this for price, and then we will take a break. Okay. So just bear with me on this. If I take price, and then rule that I can come up with is maybe less than or equal to 5, greater than 5. You have to logically look at this data and come up with some rule. Okay. I feel this is a logical rule, but if you feel there is any other logical rule that you want to apply, please go ahead. Okay. This is just a logical number. Now, if you look at left side, less than or equal to 5, then this complete region should be chosen. This one, because that's less than or equal to 5. If you take the first row, 5, is 5 greater than 5? No. Is it less than or equal to 5? Yeah, it's less than or equal to. It's equal to 5. So what does your predicted value here say? Yes. But then what does your actual value say? Yes. Wow, there is a match. Let me take the second row. It's 1. Is 1 greater than 5? No. Is it less than? Yeah, it is less than or equal to 5. So what does your predicted value say? Yes. But then what does your actual value here say? That also says yes. There's a match. If you look at the third row, it has 5. Is 5 greater than 5? No. Is it less than or equal to 5? Yes. What does your predicted value say? Yes. And what does your actual value here say? That also says yes. Now let me take the fourth row. If you take the fourth row, the value is 5. Is this 5 greater than 5? No. Less than? Yep, it's less than or equal to. What will your model say? That the predicted value is yes. What does your actual value here say? No. That means there is a mismatch. You have 3 correct predictions, 1 mismatch. The moment you have a mismatch, there will be an entropy because that is a measure of impurity. Okay, now let's look at the right hand side. Right hand side is only this portion, which is greater than 5. Okay, so here you have the fifth row. It is 10. 10 is greater than 5. Greater than 5, 10. And your model will predict that it is no. Actual value also says no. No equal to no, there is a match. There's no mismatch here, so this entropy would be 0. There is a mismatch here, so we need to calculate what will be the entropy. Let's see. Let us calculate that. Now, on the left hand side, it is this portion. So probability of x1 is how many times do you have yes out of these 4? 3 out of 4 times. And how many times do you have a no here? 1 out of 4 times. So if you solve this, it is minus 3 by 4 into log of 3 by 4 base 2 minus 1 by 4 into log of 1 by 4 base 2, and this turns out to be 0.81 something. Okay, that's your entropy. Okay, that is going to be your entropy. Entropy means error. You'll find it if at all there are any misclassifications. If this is entropy, then what is cross entropy? Okay, we'll discuss this. We'll discuss this post the break because I understand that we have learned a lot, right? So it means we need to take a break. So let me come back here and let us take a break here. It's 11:50 now. Let us connect back by 12. Okay, and let us take a break. All right, welcome back from the break, and let's proceed further. Once again, there is a link which is posted here. All the videos are there. Please watch those. Okay. When you click on this link, which is there on the chat window, just on top of that. Okay. When you click on that, you get to this and then you proceed further. Okay. There are 4 videos. Today's video is also getting, it's there for you. Okay. So let's proceed further. And discuss more. But even before we discuss more, I need to certainly get into this and do a quick recap. So, how do we measure the accuracy of the model? You measure the accuracy of the model if you have your output variable which is continuous using any of these: mean error, mean absolute deviation, mean squared error, root mean squared error, mean percentage error, and mean absolute percentage error. If your output variable is discrete, then there are multiple ways of measuring the error. Okay, we will get to this confusion matrix and all that. But then let me switch gears and explain about entropy and cross entropy stuff. Okay, that is what we are going to discuss here. Somewhere it should be there. Okay. If it's not there, then that's okay. I will any which ways. That's okay. I'll rearrange these things so that you have a clear understanding about entropy, cross entropy, and it would be there certainly here. Yeah. Cross entropy and the other stuff, right? I will clearly differentiate. And today, end of business, when you look at it, you will be able to see clearly the difference between error function, cost function, and loss function. What do you mean by that? How do we use those in our deep learning algorithms? Yeah. And since a few of y'all are asking for the mind map, here we go, the link. Okay. Keep it handy, save it and bookmark so that we do not get into the same discussion. Yep. All right. So if output variable is continuous, you have mean error, absolute error, squared, root mean squared error, mean absolute percentage error, so on and so forth. And the relationship between error and accuracy is as follows. If the output variable is discrete, then you have various ways of dealing with the scenarios of calculating the error. For that, we first understood the information theory. Information theory means if there is any event, which is very common, which has actually probability as 1, then information content will be very low, right? If you have any event where it's a rare event, then information content associated with that will be very high. Okay. And then we have entropy, cross entropy, and KL divergence, in which we discussed about entropy, which is given as minus summation of probability into log of probability base 2. Now we need to discuss about cross entropy. For this also, I think I can make a better, simpler, easy example. So let's see. So let me insert a few rows so that I might type it. Let me insert 3 more. Okay, done. So if I have an image of an elephant, Remember, what did we discuss? Deep learning is all about dealing with videos, images, audio files, unstructured textual files, etc. Say you have elephant as an image. Okay, you have an image of elephant. Given the image of elephant, say you have the actual class. In the actual class, it is written as, or you have say 4 classes: tiger, lion, cat, and elephant. So you have these 4 classes. Okay. And this is your actual class. These are called as labels, and your actual value would be, this is not tiger, this is not lion, this is not cat, but this is elephant. An image of elephant is given, and actually is it elephant or not, that information is also given to you, right, as a label. So you're looking at this image saying that this is elephant, so I'll put a 1 here. That means there is 100% probability that this is elephant. Then say you built a model. Okay, you built your artificial intelligence or deep learning model. And here you'll have the same thing, but the only difference will be, instead of actual, it will be predicted. Say your model predicted that there is 0.1% probability that this image could be a tiger, 0.15 probability that this image could be a lion, and there could be 0.05 percentage that it could be a cat. And then there is 0.7 probability that this could be an elephant. So you have your predicted class and you have your actual class. This actual class is given a notation P, predicted is given a notation Q. If I want to calculate the error or entropy in this scenario would be called as cross entropy. Cross entropy. Cross entropy is given as the same formula, I equal to 1 until the number of classes into, you take P into log of Q. So since you have 4 classes, you write it as summation of I minus summation of I equal to 1 until 4 Pi into log of Qi base 2. Now if I substitute I equal to 1 here, what will I get? If I substitute I equal to 1, you'll get minus P1 into log of Q1 minus, if I substitute I equal to 2, you'd get P2 log of Q2. If I substitute I equal to 3, you get P3 log of Q3. If I substitute I equal to 4, you get P4 log of Q4. When you solve this, you get P into log of Q. So it'll be minus 0 into log of 0.1. 0 into anything will be 0 minus. This into log of this. So 0 into log of 0.15 base 2 minus 0 into log of this 1 into 0.7. So minus 1 into log of 0.7. 0 into this will be 0. This will also become 0. This will also become 0. The only thing that you left out with is 0 into log of 0.7. Okay. Minus 1 into log 7. This will be minus log of 0.7. You'll get some number. That means that is your cross entropy. Now, this is one scenario, okay? I'll give you another scenario. Why will you get some error? Because it is not predicting with 100% accuracy. Your prediction is not 100% that it is elephant. It is only 70% that it is elephant. Hence, there'll be some error. If I were to change these numbers as follows, if I put 0, 0, 0, 1, put a 1, then what happens? If you put a 1 here, that means you predicted that it is not tiger, not lion, and not cat, 0% probability, and there's 100% probability that it is elephant. So when you solve it, what do you get? If you were to solve in this way, it is minus summation of I equal to 1 until 4, because you have 4 classes, 1, 2, 3, 4, pi into log of qi base 2. When you expand it, minus p1 into log of q1, of course, base 2, minus, if I substitute I equal to 2, p2 into log of q2 base 2, minus, if I substitute I equal to 3, it will become p3 into log of q3 base 2, minus, if I substitute I equal to 4, you get p4 log of q4 base 2. Now, let's substitute these values. P is 0, q is 0. So minus 0 into log of 0, 0, minus 0 into again log of 0, minus 0 into log of 0, because here also you have 0 and 0, minus 1 into log of 1. And what do you think is log of 1 equivalent to? Log of 1 is equal to 0. 0 into this is 0, minus 0, minus 0, minus 1 into 0 will be 0. Log of 1 is 0. That means you get 0 as your cross entropy. Means there is no error. Yes, there will be no error. If your predicted value also says 1, there's 100% probability that it is elephant, and actual value also says there's 100% probability that it is 1. So you know about cross entropy also. This is done. This is done. This is done. KL divergence is cross entropy minus entropy. Simple. You know what is cross entropy? You subtract it from entropy. That's it. The cross entropy minus entropy is KL divergence. Okay. So back to our discussion here. So model evaluation, accuracy measures. If your output variable is continuous, you measure your accuracy using all of these: mean error, mean absolute percentage error, so on and so forth. And okay, if your output variable is discrete, you can use any of these measures: entropy, cross entropy, or KL divergence. Okay, when your output variable is discrete. There are a few more things that we need to discuss, which is called as confusion matrix. What is confusion matrix? Let's get there. So I'm going to just take these values here into a table and then explain you on confusion matrix. Just the name says confusion matrix, but there is really nothing confusing about it. Okay, so let's get to confusion matrix. We shall just replicate this and Shall proceed further. Okay, so I'll first write the predicted class. Okay. And say you have a positive class and a negative class. And then here I'll write positive and negative. And then this is going to be your actual class. Then I'll write true positive, false positive, false negative, and true negative. What do you mean by these? Right? Let's solve it. These are very, very important. These are called as building blocks. If you understand these, you'll understand various things. Okay. When someone says, hey, I've been tested positive, what does that mean? They have disease, right? Positive means they have disease. COVID-19 positive means they have COVID-19. If I say COVID-19 negative, that means they do not have any disease. So you have COVID-19 positive, COVID-19 negative. If I say true, that means it is a correct prediction. If I say false, then that means it is incorrect prediction. So you have positive, negative, you have correct, incorrect. When we say true positive, what that means is you correctly predicted the positive case. True means correct. Positive means has disease. Patient actually has COVID-19. You also predicted that patient has COVID-19. It's true positive. What do you mean by true negative? True means correct prediction. Negative means negative case. So you have correctly predicted the negative case. That means actually a patient doesn't have COVID-19. You are also predicting using your prediction model that patient doesn't have COVID-19. True negative. And what do you mean by false positive? False means incorrect prediction. Positive means positive case. That means you have incorrectly predicted that patient has COVID-19. In reality, patient doesn't have COVID-19, but you're predicting that patient has COVID-19. That's a false positive prediction. Then what is false negative? False means incorrect. Negative means patient doesn't have COVID-19. Okay. False negative here means patient actually has COVID-19, but your model predicted that patient doesn't have COVID-19. This is false negative. Now, if you look at this table and if you look at this diagonal shows you the correct prediction. So if you want to calculate the accuracy is equal to number of times you have correctly predicted, that is true positive plus true negative, divided by overall predictions. Overall predictions are true positive plus false positive plus false negative plus true negative. When you solve in this way, you get accuracy. And if you want to calculate error is equal to, what is error? Error is incorrect predictions. So wherever you have false, that is incorrect. So false positive plus false negative. How many times did you incorrectly predict is given using this divided by overall count. Overall count is true positive plus false positive plus false negative plus true negative. That's going to give you error. So using your confusion matrix, you can quickly determine the accuracy and error. Very, very important question that I'm asking you guys is, out of false positive and false negative, which scenario is more dangerous when it comes to predicting COVID-19? Okay, when it comes to predicting COVID-19, which scenario is more dangerous? Is it false positive or false negative? False positive means patient doesn't have COVID-19. You're predicting that patient has COVID-19. Is that more dangerous? Or false negative, wherein patient has COVID-19, but your model is predicting that patient doesn't have a disease? Which one is more dangerous? Think from doctor perspective and patient perspective and answer this. And this is your poll question. Out of those two, that's my question. You can easily say both are dangerous. But out of those two, which one is more dangerous? Which scenario is more dangerous in case of COVID-19? Is it false positive or false negative? Please think and answer. And here we go. Yep. Answer that poll question. Please answer that poll question. Wonderful. Wonderful. False negative is more dangerous because patient has COVID-19. And if you incorrectly predict that patient doesn't have disease, this patient might die, right? So you're risking the life of a patient. Hence, false negative is more dangerous than false positive. Okay, next. Yep. Now let's get into deep learning history and applications. Okay, and we will learn more about this. Of course, there are a few more things that we need to understand, but I think this is good enough for us to get started. Until 2012, people weren't heavily using deep learning algorithms. And there is a competition called as ImageNet competition. ImageNet competition, right? So in this ImageNet competition, there were 14 million images which were hand annotated, meaning people were manually looking at that image or those images and they were giving a name to those images. 14 million images. Manually they have done it. Then they thought, this manual way of, looking at the images and giving them names is very difficult task. And they thought, let us start a competition. And they started a competition called as ImageNet Large Scale Vision Recognition Challenge. Now they stopped this for images because it's a solved problem, meaning people have solved it. The algorithms that we have, like computer, neural network, etc., has achieved an accuracy more than a human. So these algorithms will work better than humans do. Okay, and for this competition, they have given away, I think, 2,000 categories and 1.4 million images, right, for this particular competition. So 1.4 million images were given for this competition, and there were 1,000 categories. And people started using these images to predict. Okay, and here, if you look at this, it's a leopard. If you look at this, it's a motorcycle, so on and so forth. And until 2012, people were spending entire 1 year to just try to improve the accuracy. So in the previous year, say accuracy was 0.68%. For one whole year, they used to spend time on research, trying to improve the accuracy, improve the accuracy, improve the accuracy, and the improvement would be only 0.71. Means for one whole year, when they slogged, when they tried out all the various techniques, percentage improvement was only 3%. Hence, what people thought, okay, I think this is how it's going to be. But then came a guy by name Alex Krzyzewski. He was working in University of Toronto along with couple of other people. They have for the first time tried out something called as convolution neural network. Convolutional neural network. And this has given amazing results. Amazing. Approximately 10% improvement in the error over the previous year. Until then, it was what? 1%, 2% improvement. The moment they've observed approximately 10% improvement, the world all of a sudden has started noticing, taking a note of neural network algorithms, which are today called as deep learning algorithms. And since then, until today, all the competitions which are won are based on, ImageNet competition. I'll do one thing. I'll quickly open this slide, PPT, and then I'll explain. Anyways, the same slides will be there on your learning management system also. Okay, this is how it looks. Don't be scared. Don't be scared by looking at this. I will ensure that you all understand each and every portion of this. Artificial intelligence is the future. It is much, much superior than your shallow machine learning algorithms. Okay. So look at this. AlexNet has improved the accuracy by roughly 15%. I told 10%, my bad, it's 15%. And since then, all the competitions that people have participated in, they were all using only neural network algorithms, and the accuracy was just increasing. Human performance is 3 to 5%, but already today as we stand, error rate is 3 to 5%. But today, the accuracy levels of neural network algorithms is much high. That means error rate is much less than 3 to 5%. And people started using that in speech, be it Microsoft Cortana, be it Apple Siri, be it Amazon Echo, or be it Google Hello. All these are speech recognition systems which have amazing accuracy. In all of these scenarios, people have started using neural network algorithms. This is the future. Look at the percentage error which was reduced. Of course, it is almost 0% as we stand today. It is almost 0%. So that means systems are, speech recognition systems are so accurate. There is also something called as Atari Breakout. I've already, I think, shown you this. It's a game, video game. Your deep learning algorithm, you need not teach it anything. It will automatically solve it for you. It will automatically solve it, right? And this is a game called as Go, AlphaGo. It's like a chess game played by Chinese, and Lee Sedol is the reigning world champion, and he was defeated by this particular, AI, AI built reinforcement learning game. Almost in all the games he was defeated. Then Google has acquired something called as DeepMind, and DeepMind has built a system called as AlphaZero. This AlphaZero algorithm, which was developed by Google and DeepMind, just it took just 4 hours, and then it learned almost all these steps, and it crushed the reigning world computer champion Stockfish. There is a computer champion called as Stockfish. That means a computer game. It defeated even the computer game 28-1 in 100 games. Means it never lost. 28 times it won. Rest of the times it was a draw. Marvelous. Deep learning applications are used in image captioning, determining that these are pizza pieces in itself is difficult. And it is also giving a name, saying that there are two pizzas sitting on top of a stove top oven. Captioning images, identifying that there are vegetables in the image is itself is a difficult task. And giving a name that a group of people are shopping at an outdoor market, it's marvelous, amazing. And your deep learning neural networks has actually solved these problems. We look at these. Practically, we'll do it, okay? Practically, we'll do a few of the use cases. A few of the use cases, not all. Okay, because we'll not have time. Okay, that's the reason. This is a chatbot. We also have an artificial intelligence chatbot on our system, on our website. Let me quickly show you that. So this is our website. And then if you click on chat now, right, you can say, where did you first hear about us? On Google. And it says, where are you, what are you currently into? You're, say, working or studying. You can choose anything. Who is chatting with me? An artificial intelligence system is chatting with me. If I say, which type of training are you looking for? If you say, I'm looking out for individual training, then what we would like to get more information. Your name, please. Okay, I'll type my name. Artificial intelligence system is collecting the data from me. So it is also used for data collection. Wonderful. .com. And it's asking me for my phone number. I'll type that. Thank you so much for sharing in. What programs are you looking for? Say you're looking out for this. Say you're looking out for AI and deep learning. It would say that, okay, we have 80 hours training, book an appointment. So today at 2:30 p.m. It is now saving all this data that it has captured in the backend database called as customer relationship management database, and it has scheduled an appointment. Automatically, it has done it for us. And then it is also collecting a feedback. Awesome. And this chatbot, which I'm showing you, is built by a few of my juniors as part of IIT Hyderabad, right? So chatbot is saying a man and woman are holding umbrellas. Now you're saying what color is his umbrella? Now it should recognize this. His means you're speaking about a man. It should go identify this man and determine what it is, what he is holding, which color is that, and then respond back saying that his umbrella is black. See how complicated it is and how easily this is doing using neural network. If you say, what about hers? Hers means a woman, but then it also should store the previous question in memory. What color is his umbrella? Umbrella. What about hers means you're checking on what color is her umbrella. So it will go identify her and then say that she is holding probably a multicolor. How many other people are there in the image? It says, I think there are three, one, two, three, but it also says they are occluded. Occluded means one person hidden behind another. See, another person's only leg is visible. So that's called as occlusion. Amazing, right? And do you know what is happening in the world that we live in using neural network? All you need to do is, especially Netflix is doing this in a big way. If you take a specific movie or take all the blockbuster movies, okay, all the blockbuster movies, and take all the movie scripts. Take all the movie scripts of all the blockbuster movies and give that text as an input to your RNN models, recurrent neural network models. What they will do is they will automatically generate another movie script for you. So I no longer need who? Script writers. Movie writers are not needed, right? So it is automating that. This is not a joke. World's number one, right? In terms of doing analytics in the space of movies is Netflix. They're doing it in a very big way. Not just that. If you take movie script of, speech transcripts of the then US President Barack Obama, if you take all these speeches and give us an input to neural network algorithm, it would automatically generate a new speech transcript exactly the way Obama would have delivered. Wow, right? And I'm sure you all have your marriage photos or your parents' marriage photos, etc., which would have been in black and white. You just take the images, run those images through your deep colorization algorithm. It would automatically give the most appropriate color. The most appropriate color. Look at this. Look at how natural the colors are. Very naturally, it's going to give you a color. Awesome. And deep learning today, as we stand, is there in internet, cloud, image classification, speech, language translation, processing, sentiment, recommendation, right? Cancer cell detection, diabetic grading, drug discovery, many, many more. Video captioning, video search, real-time translation, face detection, video surveillance, satellite imagery, driverless vehicles, lane recognition, so on and so forth. And this lane tracking, etc., our people are working on that, and hopefully we will show it to you guys very soon. Yep. There are many other such applications. Please read this when you find time. One thing that I want to quickly tell you is data is the new oil. And if you look at this simple screenshot, you will understand on how people are making money just because they have access to data. Like you have LinkedIn, it's a business networking forum wherein you have, I mean, Microsoft has acquired LinkedIn for $26.2 billion. $26.2 billion. Wow. Right. So those are the kind of things which are happening. Anyways, these slides are there with respect to all the applications. You are free to watch that. Okay. And then now what we will do is we will take a quick just 5 minutes break. And after 5 minutes, rather than getting into this, we will get into, it's 12:40 now. Let us take a break until 12:45. Quick 5 minutes break, friends. The reason being, post break, we will get started with Python. Okay, Python programming. Slowly, we will also build parallelly on Python program. Yeah, please take a break for 5 minutes and then be back, please. Hello everyone, hope you are able to um, hear me. Now we will get into the next algorithm. Yeah, there are many algorithms, right? All these are the deep learning algorithms, my dear friend. All these that you're seeing. Perceptron, multi-layered perceptron, convolution neural network, recurrent neural network, long short-term memory, gated recurrent units, autoencoders, variational autoencoders, GANs, reinforcement learning, Q-learning. All these are, the various deep learning algorithms, which a few we will practically do, a few we will theoretically understand. Okay. Now, Python. So it's always good to learn in bits and pieces, the programming aspects also. And let me pull out the basic Python module. So we have already started off by discussing about Python, and we have already covered some ground, if you remember. Okay. And before we proceed further, I also should tell you that there are a lot of Python libraries which you should be aware of. Okay. And if I can open this mind map, if there is any in terms of the deep learning primer, this will get there later. Okay, fine. That's okay. If it is not there, I'm going to write it down here. A few Python libraries that you should know for sure are as follows. The first thing is NumPy. NumPy is used for numerical calculations. Okay, we already discussed about these, but I'm repeating again. Then you have SciPy. SciPy is used for scientific calculations. Then you have scikit-learn or sklearn, which is used for machine learning algorithms. Then you also have something called as pandas, which is used for data manipulation. Then you have stats models, which is used for statistical analysis. And then you have matplotlib, which is used for data visualization. Then you have Seaborn, which is used for advanced data visualization. And then you have deep learning libraries such as TensorFlow, Keras, PyTorch. These are all your deep learning libraries. Okay, and then we will also discuss about something called as OpenCV, which is used for computer vision. Okay, or you can also call it as image processing. Okay, so these are the various things. So let us proceed with this. I'm just importing the required libraries. As if you are importing pandas as PD, it's a shortcut, okay? Henceforth, we are going to refer as PD. Wherever you want to use pandas, instead of pandas, you'll use this shortcut as PD. So you imported pandas and NumPy. Okay. I think we discussed until here. Yeah, I think we have discussed this also. Now we need to discuss from here, empty cars. So whenever we want to read any file, you need to use pandas. Since we have already imported pandas using a shortcut called as PD, right? We're using PD. Within this pandas, you have a function called read underscore CSV. Using this, you can read a file. And there is something called as empty cards. Okay. So what I shall do is either you can run this. When you run this line, it is going to read this empty cards dataset. Using this assignment operator, it is going to assign it to an object called this. So let me quickly tell you about a few things that you need to remember. This is your library called pandas. This is called as a function. Okay. And then within this, within double quotes, you're giving the complete name of the file, the complete path of the file, along with the name of the file and the extension within double quotes. Once you read the data which is there in this file, using this assignment operator, you are going to assign this data to an object called empty cars. Okay, so this is called as object, assignment operator, library, and function. And you're giving the name of the file. Always remember this. Okay, library, function, assignment operator, object. These are the terms which I'll be referring to pretty often. Okay. This, you run it, you copy and paste the path and then job done. Or you can say import by clicking on this. I would check for empty cars. There is. So I'll select that empty cars dataset. It is empty cars. So I'm going to give that. Then click on next and ensure that you select data frame. As I have previously discussed with you all, like you have a photo frame. Okay, you have a frame and you have your photo in that. On similar lines, I'm going to have a frame. Instead of your photo, I'm going to put data into that. Just because it'll be easy for me to handle the data. That's it. So I'll click on this, click on done. Look at that. You have the data here. And in this empty cars dataset, there are a few more things that we need to remember. And those are as follows. This is the name of the dataset, right? This is the name of the dataset. This is the name of the dataset, empty cars. And if you want to refer to any of these columns, you just say empty cars dot mpg or dot cylinder or dot displacement or dot hp dot, then you can give the name of the columns. Okay. Next thing is indexing starts from 0. meaning you have column 0, 1, 2, 3, 4 in that way. Rows also starts from 0, 0, 1, 2, 3, etc. This is very unlike the other software tools or programming languages wherein the indexing starts from 1. Maybe people who have come up with Python wanted to be very different, so hence they have this. Maybe I'm sensing. Okay, then you say empty cars dot gear, meaning you want to go to this empty cars. I just remove the background color. Dot gear would refer to this empty cars dot gear. Dot value counts. That means you want the count of these values. Empty cars dot gear dot value counts. So you want the values, all these values to be displayed. And also one more thing is by default you'll have this background color. I mean, it's just that it's going to give different colors to different cells. 0 is very low, so you give a red color. 1 is very high, so you give a blue color. That's it. Remaining will be in pink color, etc. Right? That's just background color. If you check here, it will go away. Okay, you can also resize it. Right? If you feel that it's gonna give you a better, representation, you can just resize it that way. Yep. Next. If I run this function, it is going to give you an output here. Unfortunately, I cannot zoom this, but all I can do is I can copy and put it here if need be, and then show it to you guys. I think it has. This is what I've run. So let me reduce the font. Okay. So we have run this particular function emptycars.gay.value counts, and you got an output at that's 140 means line number 140. In the past, I've run 140 lines for some other purpose. And it's telling you have a 3-gear vehicle, 4-gear vehicle, and 5-gear vehicle. And in those gears, I mean, let me select this, will be easier. Okay. This part will refer to the gears. You have 3, 4, and 5. And how many do you have? Counts. You have 15 3-gear vehicles, 12 4-gear vehicles, 5 5-gear vehicles. It's just a count. Then you can use AND operator. How do you make use of AND operator? Let us understand. Go to this empty cars data set and go to the column called gear. Okay, you have gear here. And then wherever this gear value is equal to 3, so here, right? Select those and choose wherever you have empty cars mileage, which is greater than 19.2. So both the conditions. So you want to choose gear, which is 3. Okay. And wherever you have 3, when you look at the corresponding mileage, let's look at this. Okay. Is this greater than 19.2? Yes. Is this greater than 19.2? No, 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 no. I mean, wherever the empty car's mileage is greater than 19.2 and wherever you have gear equal to 3, pull only that data and store it in this object. Okay, store it in this object. So if I were to open this, look at that. There are only 2 rows where you have gear equal to 3 and mileage greater than 19.2. You have only two rows. Row number 3 and supposedly there is row number 20. So in this way, from your data set, you can put conditions and extract only that data that you want for your further analysis. This is called as AND operator. You also have something called as OR operator. This is a symbol for OR. Okay, this is a symbol for OR. So what you're doing is you're saying go to empty cars. Wherever empty cars.gear, go to gear column is equal to 3, choose those, or choose those entries where mileage is greater than 19.2, and then assign it to an object called empty cars underscore 5. So let me run this, and let me run this also. Wonderful. There are approximately, it's given here. Basically, you have in the earlier function, in your original data, you have 32 rows and 11 columns. When you apply this AND condition, you had only 2 rows and 11 columns. And when you applied this OR operator, this or this, you have 28 rows and 11 columns. You can do again different things. You can say, hey, I want empty cars where the gear is 5, or the gear is 4, or the gear equal to 6. You're writing such multiple ORs. You can. And then you're assigning it to this. But when I run this, you know for a fact that you don't have gear equal to 6. You only have gear 5, 3, 4, and 5. So 4 and 5 entries will be taken, and here we go. How many do you have? You have 17 rows which have gear 4, 4, 5, and 6, or 6. Next important thing is go to empty cars. Within empty cars, refer to mileage, miles per gallon, and wherever your mileage is in the list of this range, pull that. So what this range function does, first of all, let's understand that. 15, 21, 1 of range. What does this do? This is going to choose this as the start, 21 as the end, and it is going to have the range of numbers in between 15 to 21 with an increment of 1, meaning you'll have 15, 16, 17, 18, 15 to 16 increment of 1, 16 to 17 increment of 1, 17 to 18 increment of 1, 19, 20, 21. Because you want from 15 to 21 with an increment of 1. That's the range. Once you generate the range, you want to create a list, and let me run this and then show it to you guys. Look at what's happening. So go to empty cars mileage, go to this empty cars, go to mileage, and empty cars dot mileage means it will refer to this mileage is in wherever these values are in this list of range of numbers, pull that. And when you look at this underlying data set, you have 15, 16, 17, 18, 19, 20, 21, right? In this range, it generates range of these numbers such as 15, 16, 17, 18, 19, 20, 21. Now you're putting them in a list. Yep, list of numbers. You're generating a range and putting them in a list, a row, assume. And then what you're saying is go to empty cars dot mileage. Whatever mileage values are in this is in this list. Show me that. So it will first go to 15. Where do I have 15? It will check the entire thing. Okay, I have 15 here. It will store it in this, in this. Then it will take 16. It will scan through entire mileage. Do we have 16? No, there is no 16. Then it will go to 17. Do we have 17 anywhere? It will scan. No, there is no 17. Then it will check. Do we have 18? No, we don't have 18. 19. Do we have 19? It will scan through. No, we don't have. 20, we don't have. 21, we don't have. We have only 15. So that is what is returned. Okay. And one more thing, friends, we do not learn programming overnight. Okay. You might be having thousands of questions on these, but overnight we cannot learn. Slowly and steadily, it is a journey. Okay, today one day explain me everything about programming, all the options. No, that would be challenging. Okay, and that would also confuse everyone else. So maybe you might want to focus on this. What we will do is this program, Python program that I'm showing you, I'll tell you how to replicate it on your system. Okay, but let's focus here. uh so all right, let me tell you, because you guys might be having questions. To learn code, watch this video and try to type it. Okay, watch it maybe on your mobile, type on your computer. Do not download the file, select a line and run it. You will not learn programming in your entire life if you do that. You'll by heart, but if there is slightly different logic or if you're getting some errors, you'll fumble. So the best way to learn programming is watch the video, because we are anyways recording and giving you, and look at that and type it here in your computer. Type all this, then you will learn at least 10 times faster and in a perfect manner. This, I'm not saying this is the general rule. Okay, so don't worry about this. And if you want data sets, we can supply you with data sets. We will place those on our learning management system. Okay, we'll do it, but not now. We will do it. Okay, next. So here, empty cards, go into that. Wherever your empty cards dot mileage, so you're going to this empty cards data set. You're saying dot mpg means you're referring to this. Wherever mileage is greater than 15 and mileage is less than 20, pull only those and place it here in this object. Mileage 15 and 20, then you have all those numbers which are available, right? 18.7, 18.1, so on and so forth. But you didn't say greater than or equal to, so it will take only greater than. You didn't say less than or equal to, you just told less than, so it will take all the numbers less than 20. It will not consider 20 or 15. Next, let us create a custom function. What do you mean by custom function? If your Python doesn't give you an inbuilt function, means already it is there within Python, you readily use that and solve it. If those kind of functions do not exist, then what we do is we define our own functions. This is very, very important. Even when we learn artificial intelligence and deep learning further things, you'll be confused otherwise. Okay, please pay attention. So you're defining a function. This is how you write it. Define a function mean of I. Okay, you can give any name here. If you want to write a function for calculating mean, you give that of I. And then you're saying that how do you calculate mean? Mean or average is, if I have these numbers 1, 2, 3, 4, 5. If I say what is the mean of these numbers, what would you do? First you'll say add all these numbers and then divide it by the total count. That is exactly what I'm saying. Do the summation of all the numbers. If this is I, add all these numbers and store in A. So add all these numbers, store it in A. Then look at the length of this I. Length of this will be 1, 2, 3, 4, 5. Calculate the length of these numbers and then store it in B. So you'll have in 5 will get stored in B. Now what you're saying, so this will be, add all these, you get 15 divided by this 5, you get 3. So if you say print of A by B is 3. So you're saying print that number 3. So you define this function. Once you define this function, you have the numbers 1, 2, 3, 4, 5, x equal to. Then if you say find mean of x, in the place of x, I you're giving x, meaning it will first do summation, then it will calculate the length, then it will say A by B. That's it. It's saying mean is 3. Very simple. Okay, if you say mean of 10, it says, hey, I didn't understand, right? So you cannot give the numbers here. You have to give an object. Of course, for a single number, how will you find out mean, right? There won't be any mean as such. That's one thing. And let us look at another very small user-defined function. This is how you learn programming, my dear friends. In small bits and pieces, we will learn it. Okay. So we are writing a function. Here you can give any name. This black bold, you can give any name, your wish. You can even type your name, Karthik, Sudhakar. You can type your names. That's absolutely fine. But here you have to give this name only, DEF, definition. Okay, so you're defining this check underscore even of I. Okay, and this is all about finding or checking whether your number is even or odd. When do you say your number is even? If you take that number 4 and if you say divided by 2, and if you get 0 as your remainder, whatever is remaining is 0 as a remainder, then that means it is even number. If you are dividing say 5 by 2, you'll not get 0, right? You'll get some number 1 or some number will be the remainder. If you are having remainders, then you're saying print odd. So if you take a number, you divide it by 2, and if the remainder, so there is a difference. Okay, if I say I divided by 2 and if I only use divide, then 4 divided by 2, when you solve it you get 2, right? 4 by 2 is 2. But then you don't want this, you want the remainder. So you're not using division symbol here, you're using percentage, which is actually going to give you remainder. Okay, so let me run this function, and whenever you write these functions, two things you need to remember. Number one, you need to have indentation. You need to have indentation. Indentation means you need to give proper space like that. Tab. You on your keyboard, press tab key, then it will come in this way. And if you do not give such indentation or space, it will throw error for you. First thing, indentation is important. Number two, when you want to run any function, user defined function like this, you have to select all the lines of code and then run it. Otherwise, it will throw error. If you just select the first line and click enter, it says, hey, unexpected end of file while parsing. End of file. I didn't understand. I just ended, is what your Python is telling. So you define the entire function. Once you define the entire function, then if you say check underscore even, I'm giving the same function name and I'm saying of 10. Of 10. So if you run it, it says it is even. Okay, it says it is even number. Of course, right? So if you take a number, divide it by 2, 2 5s 10 and remainder is 0. If remainder is 0, it will print as even number. If you say check whether 101 is an even number or not, if you run it, it says no, it is an odd number. So what happened? You take 101, which is I, 101, and when you divide it by 2, you'll get a remainder as 1. 255 times, sorry, 50 times will be 100. You get 1 as remainder. If you have a remainder, you print odd. Only if it is 0, you print even. Any other remainder, print as odd. This is how you write your if else loop or a user defined function. Pretty simple, friends. I mean, I don't think it will get difficult than this, right? Your Python programming is similar to same English language. Instead of speaking in English, you're speaking in this way. That's it. Okay, then you want to check whether your number is even or odd. Okay, or say you want to just print not even odd, you want to just say print on whether, I'll put it here, say range of numbers. Okay, something I'm giving. So what I'm saying is if the number is less than 5, it will print that the number is less than 5. If the number is less than 10, it will tell that the number is less than 10. If the number is less than 20, it will print that number is less than 20. Or if there is, if it is any other number, it will say none. If it is any other number, it will say none. So here, if the number is less than 5, print this. Else if, ELIF means else if number is less than 10, print less than 10. Else if number is less than 20, print 20. Else will stop this loop. So using if, else, and else if. If, else if, and else. All these numbers are being used. So if I were to run this and store this function, and if I just apply this function, so it is range number of 10. If I run it, the answer says it is less than 20. Yeah, it's less than 20. I mean, equal to sign, you're not using it here. Okay, that you have to remember. This is less than, not less than or equal to. One final thing before we wind it up, or I think we can do a We will discuss this and then we will do something. Okay. Now, if you're writing x equal to 1 comma 2 and again set of numbers 1 2 4 and 43 and 54, let me run this and let me say x. What's there in this? Look at that. It's saying you have 1 2 and this 1 2 4 is considered to be a single element, 43 and 5. So this is how it will treat, friends. Okay. 1 is one element, 2 elements. All these put together is a third element. Then you have the fourth element and fifth element. You have all those 5 elements. Okay, you should not be confused. This is not 1 2 3 4 5 6 7. No, 1 2. This entire thing is 3 4 5. Now you can create such loops. You can say for I in 1, for I in x, print I. So this I, what it's saying is, it's saying 1 2 1 to 4 is a single element, 43 54. You're just printing out the numbers, that's it. Now if you say for I in range of 10, when you say range of 10, it will print 10 different numbers. And when it prints these 10 different numbers, it will start the indexing from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now tell me one thing. This already we discussed, I think. Did we? Yeah, maybe. Let me ask this question. If I say I want from I in range of this, and if I say this is the starting number and this is the ending number, and you want to increase these numbers in an increment of 2, then how would you do that? Yeah, what will be the answer? Please, can you all respond to the chat window? Start, end, increment is 2. I request everyone to please respond on the chat window on what do you think will be the right answer to this. Let us see how many of you all will get it right. Let's answer, please. Everyone. Wonderful. A lot of you all are responding. I truly appreciate. I mean, that's the spirit. This is how we need to learn. Okay. So let me print this and then you'll have the answers. Whoever has responded perfectly. So the first number you're starting with 1, you're increasing it by 2. So 1 plus 2 is 3. Then 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. And you need to stop because only from 1 until 10 you want to print those numbers. Then you have these set of numbers from 1 to 11. So please quickly answer for this also. If the start is 1, end is 11, and if you want to increase them in an increment of 3, then what will be the numbers? Come on. I'm sure with the kind of spirit that we have, we will be able to answer. You all will answer. I'm sure about that. Please, can you respond? Everyone, I request you all. This is how we learn. We have to motivate each other. We have to push. Yep, absolutely. Wonderful job done. Wonderful. So if I were to print these numbers, then you have 1, 4, 7, and 10. So here you'll get 1, 4, 7, and 10. Why? 1 is a starting number. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. You have the numbers. Then if you just say you range 10 comma 2, it will say, I don't know what you want me to print. It won't print anything because range is not defined. You didn't define it properly. Range from starting number to ending number in an increment. You need to have these three. If you forget anything else, it says, I don't understand. Yeah. That's how R will communicate with you. Okay. So a quick recap, my dear friends, is that we discussed about what if your output variable is continuous? What are the various error measures? What if your output is discrete? How do you measure the errors using cross entropy or using confusion matrix? Okay. Using this, you can calculate error or accuracy. Then we have also discussed about entropy, cross entropy, and KL divergence. Manually, we have solved it. And if you want to know more about the libraries in Python, we have also touched upon Python. So we have something called as Python and R packages. Okay, here, all you need to do is go to Python programming here and all the details would be there on for each of the models that you use. What library do you use? Even if you want to explore on R, you can explore. It is given here. You can just double click and then you can access it. All right. Finally, the videos will be there here. You might want to watch the videos. If you subscribe, the benefit is that for all the future videos, you'll be able to watch it. The moment it is uploaded, you'll be getting a notification. Okay. So watch the recorded video once again, please. Where will I get the mind map? I'll let you know in just a minute. First, let us conclude this portion. So here you have a link on top of the chat window. Please look at this chat window link and click on that and give your attendance. Very important. Very, very important. We will learn that, Harshvardhan. We will learn about that. Okay, please do that. Harshvardhan, we'll learn that later, Harshvardhan. Okay. And I think I have to again showcase this. All right. Please look at this, friends. And for LMS, no more chat messages, please. I request you all to please look at these things and act accordingly. Please do not put any messages pertaining to LMS on chat because other important questions will be kind of ignored. You'll be overshadowing that. Those are more important. This is take a photo, take a screenshot, and read it carefully and act accordingly. Okay, please. On the LMS front, this is the final thing. All with me? Very important. Okay. Then attendance. We will not share the attendance form on WhatsApp because only who attends should give the attendance, right? It's something like students do not come to the class, but I'll WhatsApp them to give attendance. Okay, that is not a right idea. So we will put it here itself, attendance, and you give your attendance. You cannot download and you should not download the materials, please. Because we'll give you access, lifetime access to the learning management system. So don't worry, you can access it. Oh my God. All right, friends, then thank you so much for joining in. I think our team behind the scenes is doing a brilliant job in responding to all your questions because we'll have a lot of questions and then we are very happy that your questions are getting addressed. Thank you all so much. We'll connect tomorrow and take this discussion further. Thank you all. Okay, for practice, again, the same thing. Please refer to our uh, page on social media. We'll be putting the questions there if you want to practice. Yeah, a few Python related and a few deep learning related concepts that we discuss, we'll post it there. You can always refer and then learn more. Thank you all.